In this video, we're going to determine whether a series converges or diverges by using the limit comparison test. In this case, that series that we're interested in is the sum from n equals 1 to infinity of 1 over n raised to the 1 plus 1 over n power. I've mentioned this several times before, but again, the biggest challenge with being able to determine whether or not a series converges or diverges using one of the comparison tests is figuring out what to compare it to. Looking at our original series, 1 over n in the exponent here is going to go to 0 as n gets large. So this probably looks a heck of a lot like 1 over n as far as the terms go. So we're going to compare this series to the series 1 to infinity of 1 over n. Now, we're going to use a limit comparison test here rather than a direct comparison test with this series because n raised to the 1 over 1 plus n is going to be slightly bigger than just n because we're adding something to the exponent, which is going to make n to the 1 plus that little bit be even bigger, which means that 1 over this will be smaller than 1 over n. Well, this series diverges. This series being smaller, we can't conclude anything with a direct comparison test. So that's why we're using a limit comparison test here. We don't need to worry about which one's the bigger one. We just care if whether or not they're similar. If I were to use the direct comparison test, I would need this to be bigger than the thing I'm comparing to, which, at least from what I've chosen to compare it to, that's not convenient. All right? So for a convenience factor, it's easier to use the limit comparison test here rather than a direct comparison test. All right. Just like every other problem we've done with comparison tests, we note that both of them have only positive terms. And now we actually evaluate the limit. Here's the ratio of the two terms. This is just rewriting the fractions. Here we've got n to the first over n to the 1 plus 1 over n. If we subtract exponents, we'll get 1 over n to the 1 over n. This is a limit that we should recognize. If not, use L'Hopital's rule to figure that out. Go through and evaluate the limit. That limit turns out to be 1, which is not 0. Remember, we're using the limit comparison test. We want the limit to turn out to be not 0. All right, going back to the thing we're comparing to, that's the harmonic series, so it diverges. So the original series must also diverge by the limit comparison test.